So thanks for sticking around this afternoon. Frank and I are going to be talking about master data management and how MarkLogic can change the way you master your data. So first of all, my name is Justin McKeag. I'm a product manager with MarkLogic. I've been with the company for almost 9 years now. It seems like a long time here in the Valley. So I know where lots of the skeletons are buried. No, there are no skeletons. My background has been in building out enterprise software solutions with web technologies and big data. I manage a lot of the integrations that we have today. So things like the client APIs, our entity services story that Joe Pasco was talking about this morning, and things like MLCP and the data movement SDK.
And my name is Frank Sanders. I've been with MarkLogic for 9 years. I've had the privilege of calling many of you in the audience customers, colleagues, and friends. I've focused primarily in breaking into new markets, and my current responsibilities are managing the Western sales engineering team for MarkLogic.
So a quick outline about what we'll talk about today. So I'll talk about what master data management is, why it's applicable. I'll go through a little bit about the current state of the art and how you do it with the technologies that are out there today. And I'll talk about how MarkLogic changes this and how we can do it better, cheaper, faster, more agile. Then I'll hand it over to Frank, and Frank's going to go through some of the practical ways, some of the techniques that we've used in actual customer implementations to build out some master data management style applications. So is anybody out there currently implementing or evaluating MarkLogic for master data management? Okay. So I think some of this material will be new, some of this material will be old hat to some of you. So let's get going. So I hate to keep beating this dead horse, but we're gonna use customers and products again as our examples. But if you think about master data, they're the nouns that are common among your business, and it's critical that you have a common reference point for these aspects of your business. So if you're selling products, you want to have a common way of talking about products, a common way of referencing customers. But really, what's happened is that this data is spread out throughout an organization. So you might have your orders and returns in your ERP system, or a particular address for this customer, Christy Harrigan, in a CRM system. Or you might have a different address in a different CRM system you might have acquired from a different company. Which of those addresses is correct? Why are they different? Or you might have external data. So the credit score is part of that customer profile and critical customer information. But again, it's not data that's controlled by you. And what you really want to be able to do is to assemble the complete picture of this customer, Christy Harrigan. So who decided that Christy Harrigan is a customer, and what does a customer actually mean? These are critical things to how that customer data is going to be used in your organization. Being able to determine the relationship with her, being able to determine what her purchase history is. So how is she related to other master data? How is she related to the things that make the business operate? So again, these are all critical things that you want to be able to have a common way to talk about them throughout the organization, even if the components of that particular entity are spread out over these different source systems. And the idea is not to replace these source systems. These source systems were built for a reason. These front-end systems are servicing different parts of the business, but to provide a common vernacular to talk about these core entities, this master data. Click. So what we have today is typical MDM solutions are implemented in the relational technology of the last 30 years. And we've seen over and over again throughout this conference some of the shortcomings of relational when we're trying to do these complex data integrations. So imagine all the systems that I showed on that previous slide. They're each going to have some sort of representation of this customer. In this case, we might have a customers table. In another system, we might have a different table. They represent some of the same concepts. There might be some overlap. There may be some conflict. They might be complementary. But there's no way you can tell just by looking at this schema, at the ERD of this relational schema, that this represents the same concept. So what we need is a way to describe that customer that's independent of how it's actually stored in that database. So we'll talk about how people have tackled this with traditional approaches. So the first is to establish a registry. And you can think of a registry as just a set of pointers to those records in the source systems. So you could have your ERP system, it will have the party master table, and that's where the customers, you wouldn't know that from looking at the name of that field, but that's where the customers live. And so this registry will have pointers to how you find those records. And really, the advantage of the registry approach is that it's very lightweight. So it's not going to impact your source systems. You don't have to force those upstream data providers to change the way that they're doing business. You can just record how they publish their data and aggregate that into a way that's queryable. Of course, the problem with this is that doing anything beyond locating that individual record by ID is going to be very difficult. So doing things like interleaving relevance queries across those systems. It comes back to all the issues with federated query. So the registry system, the registry approach is very easy to get going, but to do anything significant is going to require a lot of custom code. And again, with all that custom code to do that integration, you're putting the semantics, the meaning of that data, into application code that's not managed anywhere, that's only particular to that set of code. So based on the shortcomings of the registry style, some MDM providers have gone the way of the hub. And the hub is something you've heard a lot about this week. And the idea with the hub is to take copies of the source data and reframe it in terms of the master entities, the concepts behind the meanings behind those source systems. So again, it allows you to provide a rich, authoritative, centralized place to get that master data. And you can enrich that, you can aggregate it in situ. And it also provides a way to do those rich queries and enforce some of those governance policies. So again, the hub approach is really effective at bringing together all that data and providing rich queries. But getting to that canonical schema with something like an EDW or a relational database is a huge, huge technical endeavor. So what is the representation of a customer in a relational schema that provides what the CRM system has, what the second CRM system has, the ERP system has. So getting agreement on that universal canonical schema is usually a multi-year thing, and in many cases it doesn't happen. And this is where a lot of MDM endeavors fail, is trying to upfront model that canonical master entity. And also, that's not just a technical problem. This is a political problem, and you need a technology that can help by doing this work incrementally. So, starting small and getting incremental feedback, and being able to quickly adapt to changing requirements. And again, you can't stop the business to model all of your important data. You need to have a fluid approach where there's give and take with the model of your master entities and the way that business is actually operating. And so what it ends up with, to account for these complexities, is a lot of disparate tools that are bound together. And each of these arrows, so we've got over here, well, I can go to the next that overlays. So again, we've got ETL over here that's doing staging, it's doing cleaning, exception processing, things like that. You've got the relational database, which is where you're storing your actual master data along with the metadata and the exceptions. And you probably have multiple instances of this to accommodate for those different shapes and flavors and the intermediate states. You've got your application servers that are doing the rules and the workflow on top of that, and then federated search. So you need to be able to not only do data-style queries, but you want to say, where are the things that mention Christy Harrigan? Is that in the context of a customer? Is that in the context of a support case? So being able to search across all the instance data, but also being able to search across the models itself. So where is customer used? Who references customers? How are products related to customers? So being able to search over the instance data and the concepts behind them. And then being able to deploy them in services. And then all of the cross-cutting stuff about orchestration and security and all the application level stuff that go into the data stewardship. And so there are a lot of shortcomings to this current technology approach. And we've seen this over and over again throughout this conference about applying relational technology to things that aren't that one, aren't necessarily relational, but are changing. The inputs to this are disparate and changing all the time, and you need something more flexible than what's available today with relational. So what does this mean to MDM implementations? I think the real critical aspect is time to value. And it's got to be something that can be palpable, that can be understood, that can be used very quickly after it's implemented in order to get feedback, to have that iterative feedback loop. The inflexibility of the current technologies makes that time to value difficult to get to. Being able to support different domains, ask different questions of the data, support new entities as they come along. And cost, of course, is always an issue. Having all those moving parts combined with ETL is very expensive, very brittle, and it separates that context, that critical meaning of the data from the data itself. And that's now in this specialized application code that's very dependent on the source systems. And accountability is a really key aspect of this. Not only do you need to see and understand the data you have today and how decisions are being made on that data, but be able to trace that back to its source systems, be able to understand how it's changed throughout that process. So what were the transformations that changed this data? How were the records matched? So this customer, Christy H over here and C Harrigan, they're the same. We've identified them as the same customer entity. Which code decided that? Who wrote that code? When was that code deployed? So again, being able to trace all of these together, and this is all other exhaust metadata that's happening that's typically not being captured today. And being able to prove that and show your work is a critical aspect of implementing MDM today. And this gives rise to complexity. There's a lot of moving parts in that diagram that I just showed. And complexity introduces places for latency problems and places for the introduction of errors. So I think you see the punchline coming here. So what we'd like to talk about today is a new approach to master data management. And it uses a lot of the themes we've been talking about in terms of integrating data. And core to the integrating data with MarkLogic is the flexible data model. So being able to accommodate the source data in its various forms, being able to keep it unadulterated in its original format, and proving that you haven't changed it. But then also being able to manage the distilled master data from that, and being able to query across the canonicalized, harmonized master data or the raw source data. Compare the two. This is really critical to implementing and getting that feedback loop. So it's not that you have to implement all of your master data canonicalized up front, but do just enough so that you can get some feedback on it. And this is what MarkLogic's flexible data model allows you to do. It allows you to manage the final, the intermediate, and even the raw source data all together in the same place. Same security model, same governance model. And then what you can do is with MarkLogic's rich indexing is query across those. You can enrich those. You can link those up with things like semantics. And so being able to tap into all of the various aspects of the data without having to predefine those indexes up front. And again, this is all underlied with the enterprise-grade security features that MarkLogic comes with. So we've talked a lot about entities. How does that actually look in terms of our customer model? So you can imagine in our hub getting the data from the party table in our CRM. Of course, it would be a lot more complex than that. It's probably a view or something from our application that we've gotten. But this represents the view of a customer from the CRM's perspective. We can load that into MarkLogic as is. We can also grab the relevant orders for a customer from the ERP system. Load those together as is. So again, the idea here is to get that data into a place where it can be managed, where it can be understood, where it can be queried together. And we haven't done any upfront modeling. We haven't said what these things are yet, but we've got them in there into a place that they can be discovered. Now we can write queries against them. We can write code to manipulate that data now too. Their source system as is. And so we've seen what we're calling the envelope pattern throughout several places throughout this week. But this is really key in terms of designing data models in MarkLogic. And the key here is that we've got that source system in its original form, but we can also provide that master view of that customer that's distilled out of those source systems or from other parts of the data. So now I can provide a view of customers, my master view of customers, and I could also trace it back to the original source systems. And then I can also trace the other aspects of the process. Again, the important part here is showing your work. It's not necessarily the answer that's always the critical part, especially when you're facing an audit, but it's showing how you derive that answer. I've got a null field. That null field might be a valid value, but why is that null field there? Or I've got two entries for the same thing. Somebody recently filed my tax return for me. I thought that was very nice of them. But it turns out that person guessed the right amount of data in my tax return and filled it out for me. So in the California Franchise Tax Board would see two entries for my tax return. The fact that there are two entries is critical data, and you wouldn't want to lose that. That's the key insight there. So being able to store both the wrong answers and the right answers is a really key aspect of maintaining this entire picture of your master entities. But wait, there's more. And of course, your business is always changing. So you might have a different interpretation of a customer tomorrow. So I've gone from version 5.09 to version 6 of my customers. So this is my canonical definition has changed. My business has changed. The regulations that I'm working in have changed. So I want to be able to not only store my older versions of my customers, I want to store my newer versions of my customers. I want to be able to write code, document that code, store that code in the database that transforms between those two. I can do that transformation on the fly. I can materialize either the old version or the new version. And this type of flexibility is what gives MarkLogic a lot of power in terms of managing these entities. And finally, I can mark those up. Now I can query across the entire lineage of the schema changes that I've implemented in my master data here. So if we recall our infrastructure here, we've got this complicated web of integrations in order to support this, in order to have the flexibility that we want in master data management. And of course, this is the final picture. But what this isn't quite realistic. What we've actually seen in terms of customer implementations. What we usually see is people starting out like this. So have a little bit of MarkLogic in the middle, doing some of these aspects. Keep the upstream data sources that are feeding that data. There's ETL is doing some high value work. Leverage that, and then provide keep the existing services on the other side. But what we usually see is that MarkLogic will grow organically and kind of evolutionary. So it's not the big bang. As more of the data comes in and more of those entities are modeled there. So what I'm going to do now is I'm going to hand it off to Frank, and he's going to go through some of the techniques that we've used in actual MDM-style implementations.
Thank you, Justin. So I'm going to start out by talking about a couple of customers who have chosen to use MarkLogic to solve various MDM problems, okay, and the common themes that they've seen. Right? So here we have a sampling of 4: Aetna, U.S. Combatant Command, Healthcare.gov, and a top entertainment company. Right? So the unifying challenge for all of these is that they have just massive, massive data problems. Right? So if you look at Aetna, the way that healthcare companies, or rather health insurance companies, are growing today is through acquisition. So they had inherited over 200 different HR management systems and are looking to acquire additional companies. So the prospect of having to unify all that information was a daunting task. In fact, their IT teams had told them it would be millions of dollars and 5 years to actually accomplish this. So they started looking for alternate approaches, right? Knowing that regulations are changing, knowing that the laws are evolving, and that there's a chance of change of leadership either in Congress or in the presidency that could impact that, they needed a system that wouldn't work, take 3 years to show value, and then start again, right? They needed something that could evolve with them. So they chose MarkLogic, and within 9 months, we're actually able to deploy and consolidate all of those systems into one central system, right? If we look at U.S. Combatant Command, it's about getting the right information to the right people at the right time. and making sure that that information is secured, right? If you have a certain security level or clearance, you're entitled to see certain information, right? Especially in a post-Snowden world, there's strong controls on how you allow people to access that information. And this cuts across agencies, right? You have human intelligence, you have signals intelligence, you have video feeds, you have geospatial information, you have open source information. All of that needs to be secure, all of it needs to be handleable, and there's no way you're going to get one system that has it all, especially today, right? So again, they chose MarkLogic, and in a very short amount of time, we're able to actually get that information out to the consumers and do it even in disconnected environments, which means that if you're not connected to a live internet connection, you still have access to and can update data, sync it back later, right? You want to talk about a major metadata and master data challenge. Trying to decide which reports coming from which units at what times are the most correct is going to be one of the more challenging ones. So, a top entertainment company. Just as fragmented as the government can be, so too can be digital movie studios, right? The individuals in charge of these studios have tremendous amounts of control, right? If you're Lorne Michaels, you get to decide on every system that your studio is using and your production company is using, and then the studios have to deal with that, right? And these production companies make multiple shows for different studios or broadcast through different channels. So trying to convince any one of them to accommodate your format, it's just not going to happen, right? So they needed a more flexible way of doing that, and they chose MarkLogic and used some of the techniques we're going to talk about. And perhaps the most challenging data integration and master data problem, in the history of the Republic would be healthcare.gov, right? Trying to unify over 37 different states, all of their regulations, all the requirements, pulling in information from the IRS, from Experian and other credit agencies, trying to tie that all together, secure it, and make sure that you can adapt to changing requirements, and requirements that even today vary from state to state and even to the locality level. Caused all of these companies to realize we're tired of the 5-year cycle, right? You stand up an MDM system, 3 to 5 years from now, you finally paid it off, and it's time to start again because your requirements have changed, the business has changed. So you need a different approach. So here's some tips and techniques that we found that our customers find to be useful. I'm sure you're very familiar with the envelope pattern. We'll talk about a common services layer, how you can leverage semantics, and then decision accountability. All right. Just pausing so someone can take a picture. No, it's quite all right. I just didn't want to, and for anyone who's interested, I believe the slides and a recording of the presentation will be posted later. So if you need help going to sleep, you can get it. So the envelope pattern, why is it important? Well, data modeling is an expensive task, right? It can take up to 30% of the overall project cost. So you want to do just what you need to do just when you need it, just-in-time data modeling, right? And you're going to have to expand your data model, right? Either the language that you use or the application you're building or your user's requirements are going to change. It's not a matter of if, it's a matter of when. So with the envelope pattern, you can actually leave the data as it is and then just modify what you need to modify. And this gives you great flexibility because not only does it let you decide that the existing applications are going to continue to function just as they always have, and I'm going to wrap the necessary data for new applications to use, but it also means that if you have different business units with different business requirements within an enterprise, the enterprise can enforce their own requirements. A business unit within that enterprise can enforce their own requirements, and then individual groups and applications have complete flexibility and freedom in order to be able to represent and model the data that they require. So what does that look like? Well, it looks like this, an envelope, right? So here's an XML example where you can see we've got a master envelope containing a metadata element which has some canonical values we've decided on for first name, last name, and a UUID, along with a payload package that contains the raw data that represents the original application data. And if you want to see that in JSON, very similar, right? You have a separate array here that contains all the information, or a dictionary here that contains all the information separated from the raw data, right? The approaches are the same, right? It's just the syntactic sugar around it that's different. So, key thing to remember, it's envelopes all the way down. Right? There may be rationalization tasks. You may decide to make changes to your schema. But if you're ever in need of a quick and dirty data fix, You can use an envelope to get you there, right? You can store this as annotations. We can see how you can relate that later with semantics. But the idea is that since you don't have to fit this into a row or column, since you don't have to go back and change a schema, you do what you need to do when you need to do it, which means that evolving a metadata system becomes a very, very simple proposition. So any questions on this before I move on? All right. Sure, please.
So I'm thinking about like full text search, and
Yep.
so now you need to restrict it to the raw data essentially,
Mhm.
as opposed to the various envelopes you're stashing additional information on.
Mm-hmm. Well, so it's interesting. It depends on how you've configured your indexes to start, right? So frequently you can use fields, or you can simply just use the built-in hierarchical search capabilities that are already in our indexes to do that, right? Or what we also see is that the first step is to bring data together, right? Because unlike in some systems where you're starting fresh, here you're generally starting by pulling data from a variety of systems together. And it can actually be useful to try and find all mentions of a customer name anywhere, right? So the ability to have an unrestricted textual-based character match search or a fuzzy search can be a benefit as you're trying to figure out how to create that initial set of data models. And then from there, you can decide, well, am I going to address fields? Am I going to use that to restrict where I'm allowing full text search? All right. So, common services layer. So we've given you a way to flexibly model and manage your data, right? And given kind of common hooks at different layers of the business. But that just handles the data piece, right? Now you need to give ways for people to interact with and use that data. And one of the best ways to do that is to come up with a common services model, right? Or to use microservices. And the idea is that even though every business unit may have and maintain responsibility for a certain set of data, they're also responsible for making sure that a common services layer exists for interacting with that data, which means that any other provider, application, or service within the company can actually know how to leverage metadata within a separate group. So this gives you the best of both worlds in the sense that you have complete flexibility to build your applications as you need to, while exposing a layer of services that the rest of the corporation can exploit in order to get visibility into and manage that data through methods that you control, right? If you're in logistics, it might be okay to have multiple addresses for a customer. If you're in billing, you probably want the one that corresponds to where you can get the money from. But both need to be handled. So your logistics department may allow you to update an address and change an address and add an address to this common services layer, and they'll just continue to let you do that until you delete one. Whereas if you look at this,
They love
yeah,
logistics
well,
up there.
I'll take what I can get, all the help you can get, right? But from a finance or marketing perspective, you may only allow one, such that when that update or add comes through, you replace the existing information. Surface area is the same, way you interact with it is the same. However, the outcomes and how that data is managed is different. Okay.
Question, actually,
Sure.
Based on this, again, I may not be very clear on the envelope model that you
Mhm.
defined, but
Yep.
Basically there is a kind of redundancy there, right? You have the metadata from
Yep.
the fields, and also you have a raw text as you get from the source.
Right.
So now in terms of writing some microservices and all, what do you use? Do you use the metadata or?
Well, so generally you're going to use it for what works best for your business. The important is sorry?
Repeat the question.
Okay. The question is how do you marry this with the envelope pattern? Do you use the envelope for how you manage your data, or do you use the existing raw data? And the answer is that you probably want to develop your new data model as you're going, right? So if you're finding yourself managing what was once information for you just in raw data and you're unifying it at, say, a business unit level, you're going to want to start to manage that at your business unit envelope level, right? And then kind of work down from there. It's only if things don't fit into the envelope above you for some reason, or if the cost and pain of moving up a level is too great. If you're fighting and banging your head against the wall because you need to have 6 meetings in order to agree on what a first name is, where it comes from, and who and who actually gets to determine what it is, chances are it's best to say, you know what, I'm just going to keep that here where I control it and use that there. And the incremental cost here, because of the compression and everything else, is not that great, right? Because remember, it only exists and you only pay that for where you need it. This is not like a relational system where when you add a field, all of a sudden, every record in your database has that space, right? So it makes sparse problems like that very simple to solve. Right. Any other questions? Right. So I'm not an artist, and I'm not a PowerPoint wizard. But I was told that you need some images, so there you go. So you want to distribute this common services layer to each individual business unit, right? You want to get it out there across the group so that people do know how to access it. And the nice thing is that one group can maintain those APIs and contracts, and because of how MarkLogic is engineered, you can just deploy that across the enterprise, right? So, moving on to semantics. So is anyone using semantics currently to illustrate some of the relationships in their MDM solutions? In the back there? Yes. And you are with?
I am Narab. John.
Yep.
I'm with Walter Stewart.
Okay, cool. So semantics are extremely powerful, right? Not only can you create relationships similar to what Justin identified earlier, right? But you can also create hierarchies. And you can create relationships that exist outside of the data, right? Which means that, let's say that you're managing master data about the football league, and we're talking about proper football, as we discussed this morning, not hand egg. And you have a number of players, and one of those players is transferred. Or, surprisingly, you have a team with 5,000 to 1 odds to win the premiership. They'd been relegated 2 seasons ago. How much fun is it going to be to actually have to manually move that team through relegation, all of its players, around to the different leagues it may end up with? Or is it easier to maintain separately a hierarchy that says, hey, these are the teams that are currently in the premiership, right? And as a result of that, I know who's in the premiership. I know every player that plays in the premiership because I know which players play for a team. So it's not an indirect link or a direct link on every player. It's simply an organization of how football is currently structured and then the data about each individual team and each individual player, right? And you're starting to see how semantics can offer a lot of benefit to managing data and the organization of that data separately, right? Some key relationships, same as, belongs to, parent of, child of. You can come up with your own. Next version, superseded by. We've seen people in manufacturing do things like breaking change and non-breaking change, right? So if you, say, replace a power cord, in your ERP system it matters because you need to know how many thousands you have before you can ship those out to customers. But if you've got a backlog of 10,000 from the new supplier and you just replace them, you don't need to cancel a bunch of orders, you just need to replace them with a new incoming part. So, any additional questions on semantics before I move forward to our last topic? No? Okay. So decision accountability. Decision accountability is great because you always want to be able to explain exactly how you arrived at a particular decision. But it's also expensive, right? If you need to keep a history of your entire database across every change for all time, that's tricky, right? No one wants to be able to keep that online. Disk, though perhaps cheap, is not infinite. So we need a way to manage that. And we also need a way to actually execute a query as though it were that point in time. And not just that query, but the queries and the code and everything else that backed that up at that time. And for that, we have bitemporality and tiered storage, right? So bitemporality is what's going to let your application and your database know what you knew and when you knew it. So you can actually look at the history of a fact over time to see when perhaps you should have discovered something, as well as ask the question, at this particular point in time, if I ran this query, what the result would have been, right? It would be great to know if it's Monday evening and you decide to sign a contract with Lehman Brothers that sometime that night they were going to become insolvent. Chances are they're not going to tell you that. So on Tuesday, you need to say, why in God's name did I do that? Were there indicators? Were there warning signs? Is there something I should have known? From the medical field, if you're performing a panel of tests on a patient, they may or may not realize that they've developed an allergy to shellfish. While you're running those panels, they're being sent down for some sort of MRI that requires a dye that is in part based on shellfish. You'd like to understand if and when you should have known that there's potential for a reaction there, right? But keeping that history of all those changes is expensive, right? You don't want to keep that online, right? You don't need to know 40 years from now, right, in real time, whether or not a decision was made correctly. But backtesting would be cool, right? So for that, you want to use tiered storage, right? This allows you to set windows and match those windows to the value of data. So if 90% of your processing and 90% of the value that you have from your data is from within the last 3 to 9 months, then that's your first window. And then beyond that, you set another tier, right? And beyond that, an archival tier, right? And you can set up as many of these as you like. But the idea is that by using this tiered storage capability along with bitemporal, at any point you can mount that data back into a system for compliance, for regulatory, for decision making, for back testing, without actually having to impact how much capacity you have to keep available for an existing system. Please.
Right, that hasn't been done before, or it's done in a better, in a more efficient way?
Well, so the combination of bitemporality and tiered storage, bitemporality is very unique to MarkLogic, right? So we are, as far as I know today, the only NoSQL system that has bitemporal index and processing capability. And the relational systems for such suffer from the same problems that relational systems do in terms of sharding, parallelism, et cetera, right? The tiered storage capability that we bring makes that easier to handle, right? So, you know, the other alternatives are what Chris discussed this morning, right? You can do database rollbacks, you can keep copies of reports, but they give you gaps in your coverage, right? Here, you get a nice, very, very continuous view of exactly what that database looks like. Right?
And because the schemas are latent in the data itself, you're versioning the schemas along with the data. And so you're querying the database as it was at that time, not just the data.
Yeah. Yeah. So just a couple of other resources that you might want to take a look at. Obviously, Justin and I will be here answering questions as well. But we have a lot of MarkLogic University training, and specifically they've got some data modeling training up there that could be very useful. The MarkLogic developer site, there's some blog posts on there that are great. The data modeling discussion on developer is phenomenal. And we've recently released, and this was Paxton Hare and his team, the MarkLogic Data Hub framework, which will actually allow you to pull in some information, play around with it, do some reporting, set up a search-based application on top of it, give you a flavor of what some of the things that are possible very quickly with MarkLogic are, right? Okay. That's it. Any questions?
Does anybody have any questions?
So on the tiering, how many tiers can you have? Is it configurable now?
So you can set up policies. Today in MarkLogic 8, the question was how many tiers can you have and how do you set up, and implicitly how do you set up those policies? So in MarkLogic 8 today, you can assign a tier to a range index. So you could have something like last updated as a date in your documents. And based on its value, you can assign ranges to those particular tiers. And what will happen is, as you change those values, that document will be rebalanced into the correct tier. With MarkLogic 9, we're putting that capability on steroids and implementing much more sophisticated policies rather than just having it in a specific range index. So you can do query-based, for example.
And how many tiers can you have? As many files?
Gazillions.
Really?
Yeah, you could have them as fine-grained as you need. You could have them multiple years. You could have them multiple minutes. It's just you need to have the partitions are mapped to forests. So you just need to have the forests available that map to those tiers. And then there's an other bucket. So if you have data that doesn't fit into a particular tier, then you need to allocate some forests that the untiered data will go into.
So you could use this as partitioning in addition to tiering?
Mm-hmm.
If all the forests are on the same SSDs, very fast, expensive storage,
Yes.
you can use it as partitioning or tiering.
Yes.
Wow.
Yeah, so the actual configuration element is called a partition. And so you'd set up where those particular partitions are in terms of how they're mounted on disk. So you could have your most recent partitions on your SSDs, your warm data on cheaper locally attached disk, spinning disk, for example. You could have another partition that is on S3. You could have another partition that's actually offline and have some warm infrastructure that you could mount that and begin querying it immediately.
Yeah, and with the query-based partitioning that he's mentioned, you can actually set multiple criteria, which to your point of having a tier that sits on SSD, you may have different SLAs for different sets of data, right? You may have some data that runs and comes through so fast that it's only a week before you're moving it out to the next partition. But you may have other data that's very valuable that lives longer, that sits in that partition on the SSD side, actually ends up occupying more space than the others, and takes longer to get tiered out.
Question in the back there?
I'm going to jump on that question. And does the query optimizer consider that? Could I use that like for tier pruning or tier elimination to make my queries faster?
In MarkLogic 9, yes. So you could fake that today with some knowledge of the query that you're running. So if you've got that updated date that I just gave it as an example, you could know from configuration which forests that will affect, and you could limit your query to those forests. That's extra work for developers, and so what we wanted to do is push that down into the database. And so that's the type of thing with this new tiering policy that we're working on.
I have a question. See, let's say in any MDM master data solution, basically one of the important things that we look at is 360, like any party, customer 360, for example.
Yep.
So how, I understand like now you have an immutable kind of data store, let's say biotemporal, bitemporal.
Yep.
Now, do you have like some reference solution that explains how MarkLogic does that 360? Now my confusion is now you have so many envelopes, right? Your whole framework or architecture pattern is building these envelopes as you need it, right? Now, how do you actually create a solution which is like a 360 customer?
Sure. So it's entirely based on the policies of the organization you're working with, right? So if I looked at what Disney does and where they consider their customer records or their golden record, it's going to be different from how, say, an oil and gas provider would look at it, right? And some might have strong consistency around addresses, things like that. The idea is that the envelope's a patch, right? It starts as an envelope that surrounds your data. Eventually, it becomes your data, right? I think where you're sort of heading with the question is what about data quality, right? And the answer there is you'd use the tools that you already use for data quality, right? It's largely dependent on business logic, right, and how a business views it. I used the example earlier of different addresses meaning different things for different groups. And we have our content processing framework, which you can use to plug in data quality tools. We have REST-based services that you could use to plug in data quality tools. The idea is that there still is data modeling, there still is data governance, but you get to delay that until you actually have to make the decision, right? So if you start to see yourself getting a proliferation of envelopes, it's time to question, okay, what do I need to do, right?
See, that's a typical canonical solution. That's where we end up, right? This is, most probably in a different kind of solution. But most probably I see the same kind of path where you the proliferation of all those canonicals.
Well, the difference is that because you have the ability to let different models sit side by side, if you have an individual group who has a business need to implement an application with a set of data, they can add that. And that doesn't force anyone else to adopt it, right? It doesn't force every other record within the system to have that storage, have that space, have those fields, right? So it's isolated just to that group, which is what makes this different from a traditional relational approach, right? Because with the relational approach, once you add that, if you add that at a level that exists for the entire organization, now the entire organization has to store that information, right? So in this way, you choose what you need to run your business at a specific level, and then you have your governance at that level for that envelope, right? And then.
So your recommendation is governance is much not at like.
No, it exists at the level that it's required to exist, right? If you have 10 fields that you run your business on from an enterprise level, then that lives at the enterprise architecture board. If you have 20 fields that are related to a mobile application that one group is using in an area of the business, then that is isolated to that group.
So as an enterprise architect, actually, if you think about the governance, if I have to give a governance framework with MarkLogic as one of these things, basically there are multiple levels. I mean, there could be governance at so many different levels.
Yep. Yeah. And we've heard this referred to as platinum, silver, gold, etc. Right? You've got a platinum level, which represents your enterprise-wide governance. You've got the gold level, which might be your business unit. You've got bronze, which might be your organizational unit within that business unit. And then within your team, it's just whatever you need. Right?
Anything else? Well, we'll stick around here for a little while longer. Please fill out your feedback forms, and there's one more session this afternoon. Thank you.